you need to think about how do you secure that? Where is that data actually going, and how do you keep it safe, so to speak, or your device, your details, anything you don't want shared to everybody. This is what you need to think about. Now, again, a little bit on that, and we'll discuss where you might want to go if you want to go over more about that, if you need to go a little bit further into more detail and how to actually manage that in greater to a greater extent. Yeah, and well, okay, so that's basic intro is what is that we're going to be doing today. Now, first off, we'll move across to our first intro for sort of next bit about what types of networks we see across in different areas where we see them, whether it's in your home or at work in an office or so on.
So there's two main areas of networks that are used or classified. We have peer-to-peer networks, and we have client-server. So we're going to start with peer-to-peer because this is what you would most find in more of a home environment, because it's easy to set up, easier to manage, cheaper, and you're never really in a home environment going to need the resources that a larger network provides. Disadvantage of the peer-to-peer network is it's not as secure, it's not as scalable. That's a quick networking term. Scalable means to be able to grow without any obstructions or problems. And also, all the devices have some sort of security flaw in this type of setup, because essentially every device on this type of network anyway is connected together, and they have pretty much the same level of privilege. So there's a security issue there. Now, client server, Rob, do you wanna? You'll find this more in most businesses and organizations will use a client server model. So basically, you've got a central server, and all the devices on the network at some point will congregate on that one server. And the advantage of this one really, other than the fact that you have a massive load of resources available to you, is the fact that you can add individual security to pretty much every single device on this network, but also have a central point that manages the privilege and access all these devices share. So there's a lot more security and control in place, but you would very rarely find this in anything in a home, because there's no reason to expend that amount of money for a home network unless you've got maybe like 10 people living in a house. Even a smaller business, like a small shop, wouldn't need this type of network. It's when you get to the size of like an office where this is where you'd actually start to move into. But so they're the two big areas. We've got client server and peer-to-peer. In networking, they've got lots of networking in an academic way. They've got lots of namings of how you call something, but the big thing we have is something called end devices. Now, end device essentially, in the most basic term, is any device that a user is going to make use of. So a computer, a laptop, a phone, a printer, they are all referred to as end devices. So then, as you can see from this visual example, we've got two essentially separate networks, and we have a network in the middle, which is called the internetwork, which we'll get more into about what that is later. But all these devices at the ends, which the users are using, are referred to as end users. Or, as I said, networking has more than one name for them. Sometimes they also refer to them as workstations. Hence, this is where it gets a bit confusing. So if I use the term end user in any of this part of this today's session, I'm talking, or end device, should I say, I'm talking about a device that a user will make use of in some form or another. Okay. Right. Then we have intermediary devices. Now, these are the ones that are the most complex, but also the ones that some of you will be familiar with. You're at home, in downstairs, your device, BT, Virgin, or whatever provider you're using, they refer to that device as a hub. Okay, BT Home Hub, Virgin Home Hub, anything like that. In networking, these devices are referred to as intermediary devices, and because these devices are essentially the ones that make the decisions of how these devices connect. These are also where a lot of important information is stored. So things like your IP address, which is linked to, in somewhat linked to your location, information on where you have web browsed. So if you browse on go onto the internet and go somewhere, the IP address of the site you're going to is actually for a while stored on your device at home. So in the common way of saying it, as I said, is called a home hub, but it's actually a router. So in networking terms, a home hub is actually a router or routing device. And as you know, a router or a home hub at home is wired and wireless, which both have their pros and cons for their use. But in a wider scheme of things, they are called intermediary devices. So if you go into an office environment, you've got, not even just an office environment, you go to a coffee shop and you get out your phone and there's a Wi-Fi available. You're not using your Wi-Fi from home. That's not your home Wi-Fi. That is using the coffee shop's Wi-Fi, and they're providing access to that using intermediary devices. For example, a wireless router or a wireless access point. Cool. There's a bit more background information of essentially how these devices physically connect. I'm not going to go into the big details of the wordings, but we have the basic copper cabling, which is Ethernet and things like that. Most of the UK's infrastructure at home use, anyway, or even office use copper cabling. Then we've got the more somewhat better and faster. We've got the fiber optic. And I will say this is what a lot of people are waiting for. So those of you on Virgin or even BT, for a while, if you go onto your account, it says, "Oh, you're eligible. You're in an area eligible to fiber optic." When you actually click on it, it says, "Oh, but we're waiting to roll it out." I've lived in this house for like about 20 odd years, and I was told 10 years ago I'd get fiber optic. I still haven't got it yet. So it's around. It's very, very nice. It's just not there yet, basically. But yeah, and then obviously we've got our wireless. So I would say 90% of devices at your home are probably connected to your hub in the wireless sense. Because the home hub has limited access. So they might have maybe 4 to 5 ports at the back that you can physically plug into. And 2, you don't want to have a long cable run all around your house to try and connect things. So you connect to them wirelessly. And all of these have different advantages, disadvantages. They have some have got security flaws, and some of them are slower and faster than others. And there's actually restrictions in place of where you place them in a house, and how you connect them can also have an impact on lots of different things, which I'll get to later. Again, this is a summarization here. So we've got a few devices here. So end devices, we've got some computers, laptops. Now, as you can see, the image here is a bit strange and not exactly what a printer or a laptop or even a computer looks like anymore. This is actually the academic view of it using the software I'm going to show you later, which is used to create virtual networks, basically, and this is how they represent the visual. But essentially, we've got end devices, intermediate devices, and then we've got wireless, LAN, and WAN, which again we'll get into later.
Cool. Right, so thinking of those devices, you've seen those pictures that maybe didn't look so obvious about what they were, but how do we actually end up using them in the real world, so to speak? I say the real world, looking at this picture here, that's sort of an older view of things, but imagine you've got a computer there's a printer, there's a thing, and these might be your sort of home network, if you want. That printer may well be connected to your network. If there was another person in your home who also had a laptop or if you had another one and it was in another room, and you could connect that laptop also to the printer without actually having to go and physically connect it. Maybe it's you might have a wired connection, but it'd probably go through Wi-Fi these days, more than likely. And in most days now, most places we've got lots of other types of devices as well, as we mentioned already. Things like mobile phones, your laptop device. How many mobile phones do you have? If there's more than one person living in your house, if everyone's got a mobile phone, you might all connect to the Wi-Fi when you walk into your house. Automatically does it, because it did it last time, so it keeps doing it. Your TV might be connected to the to your home hub, or your router, as it's called. Anyway, you can't actually see it in this picture here where the router is, but these are all a summary of some of the devices that you may well have connected to your home network. Now, in terms of we said before about the peer-to-peer views, we don't need to worry too much about who's in charge of all that network. There is a password, and there is a thing that you connect to the network. So there's only a certain number of devices that will connect, or at least you can manage which devices are allowed to connect to your network. And basically everything just has the same access to the internet from your house, or from to various resources. You can even share data between devices in your house without actually going through the internet. That's one of the possibilities of having this home network does. So if you had two computers, for example, you could share files between them without actually having to send emails and things like that. It's a little bit trickier to set up to do that, but it's doable. It's something that one of the things that the network's for. So creating that connection, so we can move one thing to another. We can send data from one place to another place. So when you expand from this a little bit, we get something here. It's often shortened to SOHO, which is small office and home office. Generally speaking, there are just a few people in this office area, so you don't have many devices, but it's there are several people. There are a couple, maybe a few people working together to do something. It could be in your home, it could be in a small office environment, in a small rented building or whatever. And you don't need this huge mix. Again, it could still be peer-to-peer, as we said, mentioned earlier, being that you don't have many users, many devices plugged in. That could be perfectly fine. So from that point of view, if you all need to share sort of the same kind of level of privilege and so on, so you may not need all of that. And of course, as we mentioned before, about things like servers and whatever could be expensive. So one way of keeping DOS down, if you're small, you probably don't have that huge amount to lay out on all this expensive equipment. But then, of course, you may grow, and then you become like your larger networks. Now, this might be, if you imagine this as a tower block in a office block in a city centre or something, where you have lots of computers and lots of different office space on different floors in the building. You may well have, that company may well have hundreds of computers, or maybe even more, inside this building. Now, in that case, they will have servers, they will have lots of different routers, wireless access points, and all this sort of stuff. Generally, just causing that a bigger network, so to speak. Step up from the even bigger network, of course, is as big as it gets at the moment, is the worldwide networks, or the internet, as we've all heard. So the internet is a network. It's just a network of networks. So all of the networks in the world connect together to make one great big network called the internet. And that's basically what that is. Yes, and then again, how that's managed. There are lots of different areas. So obviously, each of these smaller networks are all managed within their own community. So one network in a building in a city somewhere is connected. It's managed in London or something like that. Then there's another network in Paris somewhere, which is also managed and covered there by the department that works there. But they have a connection that they can communicate with each other in that sort of way. How all that connections are managed is usually it will be dependent on which companies have leased those lines, which company owns that line that is laid between Paris and London, or which companies, because it's unlikely to be just one. there will be several different networks, different lines, power lines that cross, different data cables and things and so on that cross and so on, wherever, from place to place, or satellites from around the world. They're also using this. So who owns that satellite? Who put that there? We've heard some profile names about the Elon Musk Starlink or whatever, all that sort of thing. There's the networks of satellites that orbit our world, and who owns those? Well, that will be the SpaceX, the Elon Musk company, that does all that.
Quick fun fact with that, more specifically about the who owns what. So in Britain and the UK, a lot of the infrastructure was originally set up by BT. So when you get a new contract, when you move to a new provider for your internet, for example, when it's not with BT, they'll offer the Virgin or something. They'll often say something like, "Oh, we'll waiver the lease line fee," and that lease line fee is actually the money going to who owns the cabling. So now it's not so much BT anymore, because obviously the upgrade and change, but for a long while, a lot of infrastructure was actually owned by that company, basically.
Yes, a lot of the original networks were pretty much all owned by BT. But now, as we mentioned earlier about having the fiber optic, when like Virgin Media or someone says, "Oh, we're going to lay the fiber optic," that's now their line. They don't need you to lease from BT. Whereas if it's going through the telephone network, which it used to up until then, that they had to pay a fee to BT, which then got passed to you, and then that's how they would negotiate the cost of what is your supply, how much is that going to cost you per month or whatever it was. Some of it was they would waiver the line, and sometimes, introductory rates don't always last, do they? But we see that. Okay, so generally speaking, that's the big networks we've got there. Now, we saw a couple of things. I didn't mention this earlier, but we saw on a couple of the slides, if you were looking, we saw the word LAN, or we saw the letters LAN on that. And there's also WAN, as we got here, and those stand literally for local area network and wide area network. Now, the difference between those is it is just geographical area. So if your local area network is in one building, that is local. It's only covering one building inside this fairly small area. It might be more than one building. It might just be within a campus of a college or a university. That might be the local area that covers all the thing. But what happens when you connect that LAN to another LAN in some other area, then that becomes a WAN, which is a wide area network. Which basically just expands the size of that network. It's now a bigger thing. Now that could become to be the World Wide Web, with the biggest network or whatever, the internet, if you want to say it that way, is as big as it gets. So basically, at the moment, eventually we might have something bigger, but there we go. So if we look at this, like the image on here, so you have your home office maybe, which is a local because it's only in your house. There's in your home, and then there's there's something that says branch there, which is it can be the branch of a shop or a bank or something. They have a slightly bigger network than you would have at your home, but again, it's a local area network on its own. And this central network is again probably bigger still, but it's still local to that area. But when you connect all of them together, it becomes that WAN area. So when you look at this cloud bit in the middle, now often when you look at network diagrams like this, you might see this cloud shape in the middle. What that means is there's a lot more infrastructure there, as Rob said about intermediary network and stuff, intermediary devices. A lot of them are in there. Now, at the point when you see models like this, isn't what the same as we're not actually drawing all of those intermediary devices, because there may be lots in that cloud, and we don't really know exactly how many, or either we don't know exactly how many, or we're just not going to draw that many. And it's suffice to say that this is the cloud area. There would be a diagram somewhere that covers what's inside that cloud, but in terms of you setting up your network, you probably don't need to know what all that stuff is in there, because it's owned by different companies, like Virgin Media, BT, whoever might own these different servers and different routers and things and so on. And generally speaking, so there we go. One of the differences between different area devices like that. So local area networks, wide area networks, and it generally is just the size of the area. You've got, let's say here, because a number of users connected, but then if you're going to cover a wider area, you will be covering, there will be more people connected anyway. It just seems like a sort of naturally follows, basically, as to where that's going to be. So quick another look at LAN. So as I said already, it's generally a small area in a geographical location. There's usually less people connected, or perhaps just simply because it's in a lower smaller area. So this could well be if you work in a either in your home or schools, colleges, and so on, campus buildings, one office building, so on, that sort of thing could be a local area network. Generally speaking, you get quite high speed connections because the IT department within that area, within that office, can manage all of it. So if there's something, if they want faster cabling between certain devices in there, then they can just put the faster cabling in because you own it. So you go and get faster connections. You get something quicker, something bigger, something more powerful. Just stick it in there. It's yours. You can do that. And generally got GIF. So the idea there's great communication between all the devices within your area, within your building, within your office, and so on. WAN, similar thing, but this bit in the middle. Now you might own some of this. So some of this may well be managed by an IT department. So imagine a big company like me, perhaps Google or something like that. They'll have lots of different areas that have local area networks, and then of course they will connect all those together, which would then make a wider area network, and they would manage a lot of the infrastructure between those local networks. But not every company is as big as that. Not every company is on one of those. Most of them aren't. So that's what would happen there is the bits in between are often managed by different service providers or internet service providers. So the ISPs, people like Virgin Media, people like BT, things like that, or service providers could be people like Amazon Web Services, or could be people like Cisco or Huawei, the manufacturers or networking manufacturers and so on. It could be people like them, or Microsoft maybe could be running those things, or of course Google, as I mentioned, might be running their own servers. So when you send data from one place, from one building to another, the exact route that your data takes, it could actually be different every time, but it might go through an Amazon server the first time you send it, and a little while later you send it again, send something again, it goes through a Google server, you send something else later, it goes through a Microsoft, and so on, whoever it is that owns these things. So generally you are someone else is managing. So if there's issues, obviously that's where support service provision comes in. You contact someone and say, hey, why am I sending this thing and it's not going through, or something like that, if something's going wrong. If it's in your own LAN, your IT guys can fix it, because that's their job, that's what they do. They can manage everything here, but not necessarily this bit on that red line as we see there in the middle. That's going to be managed by whoever it is that's providing your service. First thing you would do, most likely, would be to contact your ISP, your internet service provider, whoever that may be, and say some issue, I can't connect to whichever area is. I'm trying to send this, and then you would they would end up troubleshooting for you to try and figure out why that is, and hopefully fix it pretty quickly. No, often they do. I mean, often when you get outages and so on your networks, they usually matters of minutes or possibly hours. It's most of the time it's not that long.
But we'll get to troubleshooting stuff later.
Yeah, we will get to some of that. And of course, there's the last bit we have the internet, which covers all of it. Now, this is a bit of a simplification of what the internet might look like. So you have a couple of LANs. So all of these objects around the edge here, all different LANs. We've got homelands, hospital, government, business, schools, and things and so on. and all the stuff in the middle is intermediary devices that connects those data together. So it connects all these LANs together between one place or another. Now, working those out, how that stuff is sent, if you want to send stuff from one LAN to another, the computer basically needs to know the address of where you want to send that. Well, where are you sending this, and what is it that you're sending, basically. And this is where things like IP addresses come into play. I mentioned briefly what IP addresses. You'll see a bit more about those in a moment, but basically it's just a set of numbers that tell one computer's like an address for a computer, or a computing device, an end device, if you want to put it that way. So that's how do you find that? So you just write down that number. The computer knows which number it is. If you know it, great. If you remember it, but there's devices in the middle remember lists of these, of what device is where, and then the more it uses it, and these lists can update themselves as the day presses on, as weeks and months and whatever press on. It works out where is these devices that we need to send stuff to. So the more you do it, basically the quicker it becomes. The first time you send some data from one place that you've never sent there before, it will take a little longer, but the second time you do it, it will be much quicker. And that's just generally speaking how that goes. At first it doesn't know the way, so basically it has to ask directions. Once it knows the way, it's faster.
You'll be familiar with the term cookie or cache. So that's kind of the way of talking about it. So you browse on the internet and do whatever you're doing. It collects information about you, one, to make it faster to reach your destination, but obviously advertisers also use that information, and it's stored on the cache and the cookies that are stored on your browser. So yes, that does make it simpler, but also it adds a kind of a little bit of a scare, actually, because it's quite scary that there's a lot of information that can be found about you just from your random searches. And some of it, or quite a lot of it, should I say, is once it gets out there, it's out of your hands. It's not like you can go and say, please delete my browsing data from this information. Well, actually, no. Okay, technically, under GDPR, you can. Under GDPR, there's a rule called, there's legislation called the right to be forgotten.
Yeah.
So if you wanted to, you could contact the organisation and say, please delete all the information you have on me. And by law, they have to. So you could do that, but obviously there is a bit of scare there. So
but however, they can't delete data that someone else has on you.
Yeah.
They can only delete what they have. But
so it can get quite worrying. But again, we'll talk more about how to minimize that footprint a bit later as well.
Okay.
So I just want to quickly touch on this, mainly because of quite a lot linked because of COVID and what's happened the last couple of years. Because of this, the way that we connect digitally has changed. Like, for example, now we're on like an online streaming conference. Now, we've had this technology for like a good 10 years, maybe even more, but they haven't been the most common thing. Not really. But because of COVID, it's made it much more like, this is what we have, why are we not using it type situation. And it's changed the way that some people react to different things. So, for example, one of the new trends is called BIOD, or bring your own device. Good example, my work at my college, I bring a laptop with me. I have computers there I could use. I don't use them. I use my own laptop. I'm not because I'm paranoid, just because I'm more comfortable using my own laptop. More and more that's kind of more common, and a lot of organizations support this move because that just means that they need to have less infrastructure, for example. But again, that has its own problems. Online collaboration, this kind of is some form of online collaboration as well. And obviously video communication, you can see me, hello. And obviously cloud. So, for example, this PowerPoint that you are seeing on the screen was created earlier, and it was created and shared via cloud. So, these are the new trends in networking that's in your day-to-day jobs. You send something via email to your boss. It's not going straight to that person's computer. It's going to the cloud first, which is stored on a server either locally or not locally. So this is all around your day-to-day. Your phone, your emails. When you get an email, you don't say when you go to bed in the morning. You wake up in the morning and you check your emails, and you've suddenly got like 10 emails in the morning. Well, that's because all the emails that were sent to you during the night have been stored on the cloud, and as soon as your device acknowledges that you're on, basically, it uploads all these emails that you would have got in the night. That doesn't mean you didn't get them. It just means that they're now visible because they were waiting for you, basically. Okay, so the scary things of computing, security threats, the things out there. They're everywhere. That sounds quite scary. In some ways, it's not. Sometimes it is. For one thing, most of these threats I'm going to go through, they don't target individuals. Most of them. Some of them do, and I'll acknowledge the ones that are, but most of them are targeting organizations and businesses. Every time you see on the news and they say, "Oh, there's been a data breach, change all your passwords," for things like that, that is probably one of these threats that's affected you in some form or another. That's basically what it is. So we've got viruses. So these are they're viruses that infect networks or computers or devices or your phones. That can do, essentially, they're a malicious piece of software that run on your device and cause problems. They will delete things. They will copy things. They will basically spread itself like a virus. That's hence the term virus. So it will slowly spread itself out until it kind of basically could potentially destroy your device. Then we've got worms. They work similarly to viruses, but they're a lot more slower. So they will slowly infect your device and spread itself out, and slowly it will cause disruptions and things like that. But to be honest, worms, in most cases, they're more of a nuisance. They can, if they've been in your device long enough, to cause big problems, but mostly they're not an issue. And Trojan horses, or Trojans, they're actually kind of more of a bit more worrying, in the sense because a Trojan is a malicious software that's been made to pretend to be something else. So, for example, you get a new computer for the first time, you install everything up, you turn it on the first time, connect to the computer, and then you get a message saying, "Oh, do you want to install this antivirus to protect your device?" And you install it, and there's not a problem. And then they get a message saying, "Oh, it's been 30 days. You need to now pay for this if you want to use it more." Well, an unsuspecting person will be like, "Oh, well, this has worked out fine. I might as well pay the money." Well, a Trojan, if that's what it was, will now essentially, not only has it got your bank details because you've entered them into essentially the service, but they've also been on your computer for 30 days or more, and they've completely infected your device with other problems like spyware or adware. So spyware is a device that essentially will spy on you, either from turning your camera on without you knowing, or screen recording, or just slowly stealing information that you're sending. So every time you send something out, say for example an email to a friend, it will also piggyback that little bit of information and send it to the creator of the malicious software. And then we've got adware, which, as it kind of sounds, it adds stuff to your device that you don't want it to. So you get infected, and then it installs a bunch of other things that you don't want, basically. They're both of these, so spyware and adware, obviously they're trouble for everyone. As I said, most of these attacks would be designated to an organization because they are the bigger targets. Spyware probably maybe more for individuals like us as people, but they're not the main targets. Hackers that create these things, they're after bigger targets, and if they get small ones, they get a little trick a bit of money, and that's great for them, but they're actually after the big guys. So some of the bigger ones, for example, are denial of service attacks. They're more of a nuisance, really. They're not like, they can be quite devastating, but if anything, they just cause frustration to the company and the people themselves. So for example, Facebook. You try and log on Facebook and the page says that it's not responding, or it's down. Well, that's strange. It's Facebook. It should be always running. Or Google. I've never seen Google go down, to be honest with you, but we'll have to see there. But essentially, a denial of service attack, essentially, they got so many requests to do onto this page that it just gets overwhelmed. Hence the denial of service. Good example of an accidental denial of service is when Black Friday first came to the UK. Everyone was, even though it was a scam, I'm going to say it was basically a scam, but everyone was obsessed with it, and people went onto all these online stores to try and buy things, and literally the websites couldn't handle the traffic. And that was basically a denial of service. It wasn't actually a malicious attack, and it wasn't intended because it was just people trying to buy stuff. But that's basically what denial of service is. Getting so many requests to access a service that it can't respond to them all. And it either shuts down or starts blocking them. There's ways around it, obviously, but that's kind of the one. Now, obviously, the biggest ones or the scariest ones for us as individuals are identity theft and data inception and theft. They're the big ones for individuals because obviously stealing your data or stealing your identity, which would mean loss of finances, for example, or blackmail or other things like that. They're quite more scary ones that are more for obviously organization can be affected by them. You could steal the identity of an employee, pretend you're an employee, and use that information to cause mischief. But it's not as devastating to them because they're a big company. A company like Google make millions a second. I'm exaggerating, but it's probably a lot. And so that type of threat is not big for them. Whereas an individual like us, we don't earn millions a second. So losing our identity, losing our money is much more devastating. So it's much more scary. Now, Rob, page. There's two types of threats, the classifications. In this case, we've got internal and external. Now, the reason I'm bringing these up because of either organization or at home. So you're at home, you're not even at home office, you're at home, got kids downstairs, or you got they're on their devices or whatever, and they accidentally install something that they're not supposed to. A virus, accidentally a Trojan, they don't know what they're doing. They haven't been taught, or you might not know what you're doing. And one of your devices, their phone, for example, now has a virus on it. And because of that, every device on your home network is now vulnerable. That is classified as an internal threat from a home stance. And then the external threat from a home stance, for example, is obviously getting attacked from an external source, over-attacking or taking over the device's functionality, things like that. So that's kind of internal, external threats. Now on to the solutions. Now there's some very basic ones that are very helpful. So we've got firewalls. Firewalls is very easy to set up, which we'll go into later. Literally all it does is it kind of acts as a security guard. A security guard of a clipboard. The clipboard literally says, these are all the known configurations of viruses or data that essentially everyone knows about, okay? And it has a list of them, huge list basically. And when it receives this incoming data traffic from whatever's happened, either it's a web search or whatever, the firewall essentially will look at all this information and check off this list and it'll say, yep, you're good, come on in. If it noticed something unusual, but it's unsure, that's when you get a pop-up saying, there's a suspicious activity, we're not sure about it, so they'll quarantine it and I'm going to check it out. Or in some cases, if it's downright definitely not right, it will block it and it will say, we have blocked this because it was dangerous. Simple as. And the firewall's nice and helpful. Then we've obviously got antivirus software or anti-malware software, which essentially, a lot of these now come inbuilt with firewalls now. And what they do is they scan your computer looking for threats. And then they scan them. If they find them, they delete them. Nice and simple. Well, again, we'll show you later how to install some of these. We've got a few more complicated ones that really aren't used in this sense, but we've got access control lists, we've got dedicated firewalls and VPNs. You've obviously seen, if you watched YouTube, you've seen lots of adverts for VPNs, which stands for Virtual Private Network. And all it really is you connect to an external that has a more secure network than you, and then your traffic is routed through that external source. That's basically what it is. Okay, Rob? And essentially, depend on the situation and what you're doing at home, whether it's personal, private use or business use, you would have different levels of security dependent on what's been recommended to you or what's not been recommended to you. Home use or even basic use or even small business use, a firewall on each device, an antivirus setup, you're probably okay. If you're a little bit more worried about security, then yeah, maybe use a VPN, but probably not so more than that, to be honest.
Okay, so I installed an antivirus. So there are lots of different options available for this. I'll just say that. This is something that's called Malwarebytes. This one. There are lots of them. There's loads of different options for them. And usually, what you do is you probably hear one from your friend uses this one, or someone uses a different one, and so on. There are many of them out there, and even now, as most operating systems, Windows, for example, if you've got that, it has one built in. It's a thing called Windows Defender, which is an antivirus and a firewall in one. So usually, what happens, you just pick something. So this one, I'm going for this one called Malwarebytes. It's asks you, do you want to install this, and so where do you want to install it? Run the thing. Generally speaking, it's going to put it on there, and then it will run. It will continue, as Rob said, to scan your computer and just check the security guard on your computer. Basically, is the thing supposed to be here? Is that actually files that you're supposed to be using? So have it on there. When it installs it, puts it on there. Most of them will push a premium version, so they'll offer you a trial version in some way to say you can use this for however many days it is. That one said 14 days. Sometimes it's a little longer, sometimes it's a little less, and you can get your pro version, which will cover more bases. They varies a little between which company it is that's offered the device. What is it that they're going to do with it? But there's usually always a free version as well, which offers you very basic protection. It's going to look for anything that's a virus, but maybe not specific types of virus or whatever. Or that, without going into too much here, there are different ways that viruses affect or where they can reside in your system. It could be on your hard drive. It could be in different parts of your computer, in different parts of hidden away somewhere. And there might be some places that it doesn't check. Which they'll tell you should get this pro version because it checks all of those places, and it's one of the options. For
home use, a basic free one is probably not. It's okay. For example, as Rob said, the Windows Defender, I use that for my home use, and it's absolutely fine. So maybe if you're running a home from you're running from a business, maybe you want to up the security a little bit, but you're probably okay otherwise. Mm-hmm. Now. This video here, very shortly, we're going to show you before we move on because we're running low on time.
Yeah,
it's literally how to check if your firewall is enabled. So you literally just go on to Windows Defender Firewall.
It's Windows Defender, yeah.
And then any settings, you go into your firewall settings, and it will basically just say it'll give you a green or a red. If it's green, that means it's activated, and red if it isn't. This one here is literally just editing the settings to make them a little bit more protected. But essentially, that's just a way of just checking, is it working, basically. Well, Windows Firewall is a good version because it uses both, basically. It has a firewall and an antivirus.
Yeah. Okay.
Okay, so I'm not going to spend much time on this because this is running out of time, and this is quite... gets quite complex, but essentially a GUI, graphical user interface. You can see this here. This is Windows 10 or 10? 10. Windows 10. Graphical user interface Windows 10. Before that, we didn't have that. We had a command line interface. So, Rob, do you want to go to the next one? This is what a command line interface looks like. We'll show you something a bit about that later. But essentially, a command line interface is literally, instead of having a nice visual what you're doing, instead of dragging a mouse and double click to run a program, with the command line interface, you have to command it to do it for you. So it's a bit more intrusive. It takes a bit longer to do. It's a bit more harder, but they both do the same thing. Now, the reason why we're doing this is because with networking, in like a job scenario, you will often use a version that's similar to a GUI, but also similar to a command line interface. And if Rob, if you want the next one, it's referred to as an iOS. Now, before we get into this, Rob reminded me about this earlier. This isn't the Mac version.
Yeah, it's not Apple iOS.
It's not Apple iOS. This is a specific system for networking. Essentially, it's a combination of a visual, which not a lot of it, but a combination of visual and a command line interface. Now, a quick distinction between the two, in the sense of a user. A normal user would be much more comfortable with a GUI than the command line interface. That is why, which we're going to demo in a moment, it's when you're at home, more often than not, you're going to be making use of a GUI setup. Whereas if you're in an industry setup, you'll be using a command line. Rob, if you want to jump to 29, then we'll jump back.
Okay.
To 2 along. Yeah, this one. So you'll be more familiar with this. This is Virgin Home Hub, and to set it up is very simple. You get a box like this. You can either call someone or a technician out, but they charge like 50 quid or whatever. It's not that difficult to set up. So if you Rob, next page. As you can see on here, it's very simple. First thing you do is you want to find a good spot for it. It needs to be obviously near some sort of like a plug socket, for example. It needs to be near your external components that go out into the World Wide Web, but also it needs to be free from any stronger or other stronger waves of radio waves. So, for example, a microwave. You'd never want to stick a home hub next to a microwave because that will severely impact your wireless, or babe monitors, fish tanks, things like that. All this, the fish tank is not because the fish somehow managed to interfere it, it's the water. So the radio waves, it's harder for radio waves to travel through water than it is through air, basically. Okay, so where you place your home hub is also quite important. So you want to make sure you're away from these other busy signals. Then you've got you plug in the cable. So these are the cables that you provided. You plug it's like a white cable with a black label. This is for Virgin, but it's very similar you get for other ones. And then you connect it to the power tab, and then you plug it into a wall socket. The wall socket may look a bit different. It might have a pre-built it depends who set up the house, really. You might have a pre-built socket, or you just use an adapter which comes with it anyway. So again, it's not too complicated. And then essentially after you plugged it all in, you turn it on. So you turn it on, you literally just turn the power button in, and as the hub will start up, it will connect to the network and the lights will start flashing, and it will give you a green light. And then there will be, so for example, the Virgin one, if you go back to 29 quickly, Rob, with the front visual, we've got there's a 5G and then there's a 4G. The new Virgin only has one, actually, so only got 5G, but essentially it will be flashing a little bit, like a flashing off and on. To be honest, if something's going wrong, for example, it would actually flash yellow. So if there's actually a problem, it will give you a visual colored indicator. Also, where there's a tick which is there, and there's them two lines going back and forth. So the tick obviously is saying, yep, everything is good. And the two lines is actually showing, the two arrows connected together, showing that there is a connection established between the two, and it's going back and forth. Any lights that's not blue or green on here would mean there's a problem. Like a yellow light, for example, means there's some sort of problem going on. Now, after you do that, Rob, do you want to go back to the 2032? The last thing you need to do is at the bottom of the home hub, you'll get the pre-given Wi-Fi name and password. Now we'll get into what to do with that later, but essentially to connect to that is very simple. You go onto your mobile device, go onto the Wi-Fi settings, and then enter the Wi-Fi name and password, and it connects it for you. Now this is where one of the security things that you'd want to do at home to make your house more secure. Robbie, if you want to go to the next one, and I'll keep on going. So you've got the ability to change your name and password of your home device, and I definitely say you should do so. You would either, and this is one way of doing it, you will go on to the IP address which is given in the one of the help books that comes with the device. You enter the IP address and you sign in it with the password they've given you, and then you get the next box, which essentially says wireless security, and this is where you can actually change the network name. So that's one of the things you should do, because that network name will change to something that means to you, and also it will be different to the actual database which is stored on the company systems. So for example, you might change it. So for example, in my street, someone's named their Wi-Fi name the White House. Yeah. I changed mine to Hogwarts. Yeah, so you can change it to anything really. Obviously, there's probably some restrictions, but also you can actually change not only the name, but you can change the password. And the reason why this is important is because if your internet service provider ever gets hacked and their data is compromised, that data will include the pre-given password and network name. So by changing them on your system, you're adding another layer of security.
It's also mentioned a lot of the default names. Those ones here are written on the router when you get it. That sticker on the bottom, that's what's written there. That where it says VM 5255 or whichever it is, that's what's written on it. So if you know, it's if you get those, you usually get several little cards that have those numbers written on them. If you accidentally drop one outside your house, someone walking past could pick it up and they know what your Wi-Fi is, so they can log in from outside. Because your range will go a little bit further than the boundaries of your house, so they certainly could just sit there and log into your Wi-Fi.
Yeah.
But not if you've changed your password and changed your ID, the network name.
Okay, so we've compiled a when you're troubleshooting your network, that we've compiled a few things that you might want to do if you have any problems. So, for example, if you're using a laptop, for example, and for some reason your connection to the internet keeps on going off and on, one of the things you can do is you can restart the actual device itself on the home hub itself. So you can do that very simply. One way to do it is essentially just to press the power button and hold it down for something like about 10 seconds and leave it off for about a minute. Okay, doing that, and some of them do have a reset button, so that's an option too. The other way, because sometimes it doesn't work, sometimes it could be that it's not the device's issue, it could be a problem with the connection to the internet service provider. So what you can do is you can restart the home hub, and to do that you turn off the device. Reset the home hub. You turn off the device, you unplug everything, give it about a minute, plug it back in, and then turn it back on again. And then what it will do is your device, once turning back on, it will try and re-establish itself to the internet service provider, which then it should try and find an update which may fix your problem. It may not. Okay. The other way to do it is most internet service providers now provide an app. So, for example, Virgin Media provide an app that you can open, and on it will list all the devices you have connected to your home hub, but also has a button you can press that reboots it. Click that, it will reboot your home hub, and that may fix the issue. Okay. Now, there's another issue, for example, slow connection. The connection, there's two things that could be. One, you could be having cabling issues, where the device is either plugged in directly to the home hub, or it could be the device connected to the home hub to the outside. There could be something with the cable, or you could have too many devices connected. Now, there's something called bandwidth. Okay, and each on your internet and your connections, you have a limited amount of bandwidth. Now, think of a water pipe. Okay, the bigger the water pipe, the more water go down there. Okay, essentially, it's the same thing with bandwidth. The higher the bandwidth has been set up for this for your network, the more data can go down. However, the more devices connected to that one data stream, the more data it's going to be processing. The slower, or the more devices trying to connect and send and receive, the slower the connection will get in. So you could, say for example, you're trying to download a large file. Well, check what you got plugged in. Is your TV still connected to the Wi-Fi when you're not using Netflix? Is your laptop still connected to Wi-Fi when you haven't turned it on? That stuff is still got a connection, even if it's not actively using it. It still will slightly slow things down. Poor Wi-Fi connection. Again, check positioning. Where have you placed it? Check for any interference. Doors, wooden doors or brick walls, these all have interference. Also, there is a limited range of your Wi-Fi. There is a limit. So, for example, you can use Wi-Fi boosters. They're literally plug in. devices. You plug them into a plug-in socket. You set up the device to connect to your wireless connection, and what it does is boost the signal. Doesn't do anything fancy, it just makes it so it boosts further. Now, I'll put a little note down. So this is one thing you need to be careful of when your internet provider says, "Oh, I'm going to give you 200 megabits per second speed." The connection speed advertised by the internet service provider is for wired, not wireless. Okay, just because they're selling you 200 megabits per second doesn't mean your wireless is going to be that. Okay, you need to ask them how much your wireless should get on average. For example, my home, I'm paying for something like 250 megabits per second. My wireless barely gets 50. Yeah, whereas if I plugged it straight in, I'd get a good amount. Yeah, so just make sure you don't get sold by the giant internet connection, because if you're mainly using wireless, you don't necessarily need to spend a lot of that money on the larger megabits per second if you're not going to using a wired as much.
Okay.
I'm going to go to number 36. And then we've got a quick summary of the do's and don'ts. Essentially, just to make it a bit more easier, we've showed you some of this stuff. So change your admin credentials. That's a big one. Set a unique name for your home network. Again, we've shown you that that's something you should do. Employ a strong passwords. I know people say this all the time, but you really should. A letter, a number, capital letter, and
so on. Yeah.
some sort of special character. The more complex, the better. About seven length long is probably good enough, but that is a thing. Stay on top of your updates. Every time you update your antivirus, it is downloading a whole new list of potential problems that your device is currently not blocking. So staying up to date is incredibly important for everything, not just your antivirus, your router, and your home hub as well. Consider limiting the amount of connected devices you have. If they're not using them, why are they still connected to Wi-Fi, for example? Yeah. Don't share your passwords. That's obviously a very much obvious one. Even if it's accidentally, don't ever email your password or message your password to someone, because these messages can be compromised. They can be stolen in between. And obviously, don't write down your passwords down. What I mean by down, I do mean write them on paper, but also don't write them on your screen using like a notepad, because that can be stolen using a screen recorder. Okay, so if you don't want to if you can't remember all your passwords, use a password manager. There's loads of them online. There's lots of free ones. All they do, password manager, is literally store all your passwords, make it so that it's encrypted, so they're very hard to get, and the only one who accesses them is you. They're not foolproof, but it adds an extra layer of security. Okay, I believe we're running out of time.
Oh, wait.
So we'll just get to the end. We were going to do something else, but we've definitely run out of time. Sorry about that, people. So what we've gone through today, and very basically anyway, because this is a very, very wide subject. If you want to go into this, there's a company called Cisco. They're a worldwide networking organization that provide a lot of infrastructure and devices, and there's a lot of free training actually on this as well. There's a website called Netcad, which you can see here. You can literally go on there, create an account, and you can access to quite a lot of free resources. They're not the best because it's free, obviously. Or, for example, what we went through today is a part of the CCNA qualification, which you have to do an instructor-led version of it. So, for example, we're from North Arts College. We're a Cisco Academy, so we run the course. But if you go onto the website, they also, if you can't get to Stevens, obviously, there's also on the Netcad website, it says other places that also do this type of qualification all around the UK. Okay, because they're a large organisation, and they also do offer online variants. Okay. So you can sign up for this for free, the Netcad, to do the free stuff, but to do the more in-depth stuff, the stuff that's going to get you a job, for example, if you want to get a job in networking, you're going to have to do the higher levels. They will require a lead course, like, for example, through North Arts College. Okay. And next, any questions, basically, people?
Where we go?
Thanks. Thanks, Robert. Really practical talk there. Loads of tips in the solid device for configuring and securing and even troubleshooting your home network. We've got a few questions. So I'll start with this one. If you take one step to secure your home network, what would it be? You mentioned lots of different ones like firewalls, antiviruses, VPNs, passwords, and Wi-Fi settings. So if you're going to check any one of those things or do any one of those things, which one do you think is most useful?
Probably the first thing you want to do is change the credentials, like we mentioned about change the network name and password. So it's
the bare minimum. If we're thinking about the bare minimum thing, then I would say change your the password and the name. That's the bare minimum you should be doing. If you're that worried, then I would say a VPN. That there is a lot of hype about them. Don't get me wrong. There's a lot of hype about them, but they do their job. If you're that worried about your internet traffic being stolen or you being made vulnerable to the websites you're connecting to, then yes, VPN would be like the more paid step.
Yes, a lot of companies give you a work VPN to use when you're for your working. There's lots of companies advertising VPN services who say that when you're browsing through a VPN, it's safer. How true is this claim?
It's safe in the sense that as long as that organization itself hasn't been compromised, then you're good. So, because essentially, how it essentially works, you will see it. So if you ever when you open your web browser and if you look at the bar on the top, the URL where you enter the web address, there's a little lock symbol. Yeah, that lock symbol means that there is a protocol called HTTPS activated, and that stands for Hypertext Transfer Protocol, and the S stands for secure. And all that means is the connection between whatever you're doing is encrypted. It's not the most powerful encryption in the world, but it's encrypted. VPN adds that encryption and adds another level to it, makes it much more secure, and also all the stuff that you're doing gets routed through the company's firewall and all that stuff. So you connect to their VPN and all the stuff that you're doing gets routed through their protection. So it's kind of adding another layer to it. So not only have you got device protection in your device, you've actually got their protection in place as well. And there's a high level of encryption in place, basically, in a very basic sense, basically.
Yeah, you mentioned about there's connecting to like a company VPN and then benefit from all their hardware. Do you think it's worth purchasing a different router and not using the hub that's provided by Sky, Virgin Media, whoever else? Do you think it's worth purchasing a different router with?
And this is where it gets a little bit controversial. Virgin Media, things like they don't like you they're not using their stuff. So, for example, I one time when I was trying to change it to a new to my own one, you have to get there's information that you have to get from them to be able to do it, and they take a lot of sweet talking to get this information out of them, because they like to have the control. So having your own device set up adds a level of control that you won't get using provided by the internet service provider. They have much more control, but also they've got more responsibility, because they're the ones that essentially they're responsible for maintaining the device, but also making that their end is secure. If you set up your own device, you've got more control. You can put more security features in place on that device that you want to have. However, then you are that's more responsible. Then you are more responsible.
Yeah, they won't maintain.
They won't maintain a device that you put. And as I said, there's a knowledge gap. To be able to set up your own device is much harder than setting up an internet service provider, because a lot of it, I didn't get to show it obviously early on because we ran out of time, but with the internet service provider, a lot of it's like clicking next and things like that, whereas set up your own device, there's a lot more commands in place. It's much more hands-on. Still possible for users. There's loads of free guys on the internet, loads of them, so you could do it on your own. It's just there's a higher technical level to do it.
Yeah, thank you. That's a really really good answer. So a little bit of so you've spoken about antiviruses and firewalls. You showed one up on Windows 10, I believe it was, and I'm sure you can do the same on Mac and Linux and that. But what about Android and iPhone? Do these devices need? Do you think these devices need antiviruses? I've seen apps out there for it. What are your thoughts on that?
When you download something from a Play Store, for example, all the stuff that's been uploaded over there has already been vetted. So all the stuff that's uploaded on Play Store or whatever the Apple version, I don't have Apple, I'm sorry to say, but whatever they have, they've already checked it. They've said, yep, that's fine, that's safe. They're not going to do anything with it. You're safe using that. So there's a little more protection in place because they're doing it. It's when you're downloading something not through, I suppose, verified sources that puts your device at risk. Where that's where you want to maybe add a level of security. For example, when you're going to a pub and then you connect to the open Wi-Fi, that can be quite dangerous because anyone can be connected to it, and there's no vetting in place. You could be a hacker sitting in the room having a pint, connected to that open Wi-Fi, and waiting for people to log into it, and then straight away you've got a way to connect to them. Having a device like as I said, there is inbuilt security things on the phone, but having a like AVG, for example, on your phone that will help scan and help look at the device and data coming and going adds an extra layer of security.
Yeah, so also often with the ones we were showing earlier where it said download Malwarebytes or things like that, often if you do those paid versions, one of the extras they offer is to protect your mobile devices as well. They will say, you put in your device and they'll add the extra protection to whichever mobile devices you actually have, whether tablets, phones, whatever. Often once you pay the subscription as well, that's an unlimited amount too. They'll say, we'll protect all of these devices. There's one of the extras that they offer. You could, of course, have separate things on each device if you have it. You could have one on your Windows machine and then something completely different on your mobile phone if you want to. That's fine. But yeah, if you wanted to cover it all in one, that's one of the big things they offer.
Phones are quite secure though. They're made to be secure. I mean, companies that make phones literally put out bounties, and bounties are basically like, come hack me, basically. And they say, oh yeah, if you manage to break this phone, we'll give you 10 grand. And a lot of them take a long time to get through. So they are very secure as it is. It's what's not secure is the user when they're using it to connect to things that aren't secure, or downloading something they're not sure about. That is where the problem can occur. And having that extra software on there does add an extra layer to protect you, basically.
Just one last question. So what impact do you think working from home has had on cybersecurity? I suppose both for the both for home cybersecurity and also for industry as well. That's a tough question.
I think there's been a lot more attacks. There's been a lot more variety of attacks because we've been at home more. The amount of actual internet usage during the day has increased a lot because more people are at home, like with the kids in schools. There's a long time high. So that the types of attacks that have been happening because of that has increased, and the variety of attacks have been increased because of there was that thing during lockdown where it was not Teams. There was another one that essentially they were like, I think it was called House Party, and they were literally just a collaboration like this where basically you can play games together and stuff. And there was a huge thing about them data leaking and stuff like that. Well, they had millions of people connecting to the device, so there was a lot more variety of attacks, and because of that, it's kind of woke the security industry up a little bit because they realized, hang on, this is how many people could be using the devices on a normal day-to-day. Say, for example, normal day-to-day, we've got in the UK, we've got at 12 o'clock, we've got 20 million people using their devices. We get to 5 o'clock, and that's 50 million people. During lockdown, we had much more high traffic all times because you were at home.
It's
So
a
post
huge
that,
increase in the amount of devices and different types of data and different uses, and all of that had to be considered.
yeah.
What
So
kind
yeah,
of information is being sent from one place to
it's made
another?
a very large impact.
Yeah.
Very large impact.
Yeah, so that's all. That's all the questions. Thanks for your time this evening. It's been really good and fantastic answers to those questions as well. Really, really insightful. So to our viewers at home, if you've enjoyed the presentation this evening, please like and subscribe. You can also press the bell icon as well, and that'll give you a notification when we upload content. Once again, thank you to Robert, and thank you to you for watching this live stream. I hope you have a nice evening. Thank you very much.
Right.
Bye.
Thanks, guys.